Have you ever wanted one rig to rule them all? Today we're going to be setting up a killer home server, and this is going to be the ultimate Homelab AI rig all-in-one build, and it's going to be powered by Proxmox. We're going to be using LXCs and Docker. We're going to have awesome capabilities to do things like snapshot, backups, and reverting really fast, and that's going to help both of us as we get better and better at practicing and deploying different AI systems. As well, this can house any type of other system, including virtual machines, and the way that I'm going to show you to do this today, they can all share the same GPUs. I hope you're excited. I know I am. And if you haven't taken a chance, I put this rig build together. If you're wondering what the reference looks like in a prior video, you can find a link to that in the description below. While you're down there, if this is the kind of content you like, be sure to hit subscribe, and also drop me a comment and let me know what it is you are hoping to get out of a Homelab/AI home server. What kind of use cases are you envisioning? The powers that this brings? Oh man, this is so cool. I hope you're excited. Let's get started. Well, the rig that I'm using today is designed for a very specific use case of being able to fit a 7DB with quad 24 gigabyte GPUs in it. This same steps will apply to any rig, and all of the rigs that we're building in the future, including the economy rigs and the mid-size rigs, should follow along on these same steps. This is going to provide you with a very flexible platform. So to start with, go ahead and download from Proxmox in the downloads and the Proxmox virtual environment. The current ISO installer, whatever the most recent is, go ahead and download that. I've already got that downloaded. Next, go ahead and grab the Rufus Portable. And if you're wondering why I'm not using Ventoy, check in the video history on this channel to see a really good description of why I am not, and it might be something of interest to you also. But definitely, I'm using Rufus. That's also a good alternative. Go ahead and start up your Rufus and select the image from your desktop for the Proxmox installer. And it's already selected the USB drive that we've got here. Any USB drive will do for this. I've just got a plain old 32 gigabyte. And so when that's done, we can go ahead and take our USB drive and plug it in to our GPU server. And we're logging into the remote interface, and I'm going to pop up a remote HTML5 session so that we can remote control the machine over there. This is, of course, the BMC functions that I've talked about a couple times on this channel that are very nice. If you can get a system that has that kind of access, it really allows you to put it almost anywhere. And we'll select the graphic mode for installation. And we're going to install this to an NVMe. And I always like to back it off a few gigabytes just in case you grow to the end of your file system on there. It can sometimes create problems if you can't grow, and give yourself some extra space to recover things from. The onboard 1 gigabit for the management interface, which is what this is, and then our other networks we can propagate off of other connections. And this is actually going to live at 1.30, and that should be 192.168.1. And this is prox0.spaceportdigital.com. And after you finish the installation, it's going to tell you to go ahead and give you an IP address that you can go to. And we're going to go to that IP address over here for me and click Advanced to allow the SSL certificate, which is self-signed, to be authenticated. Go ahead and enter the credentials that you created earlier. Click on OK that you don't have the subscription. Now, the first thing that you're going to do when you're here is go ahead and click on your Prox0 and scroll down to Updates and find your enterprise ones here. Click Disable and Disable. And then we're going to add the non-subscription, and that is that one right there. And go back up to updates, click on refresh, and this will pull from the free update library so you can get updates without paying for the enterprise subscription. Okay, click on upgrade, and we'll upgrade these packages. Okay, and it's going to let you know that you should restart to enable the new kernel, so that's a good idea to do. So we'll just go ahead and click reboot now. So the next thing that I'm going to do is I'm going to set up a RAID mirror, and that is essentially like a RAID 1 of the two 3.84 terabyte NVMEs that I've got in here. So we've got our storage now set up. So now we have our machine set up, baselined. You're going to have to make a decision, so I'm going to outline that decision for you here. But I would like you to also consider that you have the flexibility to not just be locked in by that one decision, but also you could potentially make a couple of different decisions. So you're going to need to decide whether you want to run this as a container, and that would be either an LXC or a Docker container. Now, it is against official recommendations from the Proxmox team to install Docker natively, and it has been reported to cause issues with networking. I've not done that myself, and that's not the method that I'm going to show you here today, but that is, let's call that the outlier. And you would possibly use something to manage it outside of that. I would imagine that you would use possibly like Podman, maybe Portainer. There's probably some others out there that you could also use. Dockge, that's one that's pretty popular. Second, you could install it as an LXC. So running an LXC with Docker inside it is what we're going to do here today. And that means a couple of things. One, that's probably the most flexible way to use your GPUs. Your GPUs will not be passed through into the LXC container. Your GPUs will be natively accessed from inside the GPU container. So Docker will pass through that communication into LXC, and LXC will communicate pretty transparently with your GPUs, giving you really good performance and also allowing your GPUs to be used by other LXCs on your system. That's really cool and really flexible. The third way, and probably the officially supported way, would be to install a virtual machine with Ubuntu like 22 on it and go through the setup and installation there. That certainly would work. However, that does come, in my opinion, with one big downside that you have to consider. That locks your GPUs that you would be passing through into the virtual machine to that virtual machine. So while that virtual machine's running, you will not be able to use those GPUs with something else. However, I will say this, as long as that virtual machine is off, you could access those GPUs from a different machine. However, running LXC at the same time, accessing the GPUs, and then passing them through to a VM is a recipe for disaster. What we're going to do is just go ahead and pass it through to the LXC. This means we're going to install Nvidia Container Toolkit and the Nvidia Drivers on the system, which is going to be the Proxmox root, so the base system, which is based off Debian 12 Bookworm. And then after that, we're going to install an LXC container, which comes from a script site that I'm going to show you that has a bunch of handy information. And from there, we will be able to access those GPUs with just a couple of config changes. So you can find these written directions also on digitalspaceport.com. Link to that in the description below. So I'm going to go ahead and fire up the terminal. If you don't have the terminal, you can get this from the Windows Store. This is a nice way to interact with command lines. So we're going to SSH into the IP address, but with the user root at and then 192.168.1.30. And it'll ask us if we want to add the SSH fingerprint, and we will type yes. And then we will give it the password we created when we set up our credentials. And so now we're going to go ahead and install the kernel headers. So type in apt install PVE headers $. Uname -r. Install the Nvidia packages needed. Next, go ahead and do an apt update. You can see that we've got the Nvidia repos now listed in here. And let's go ahead and install the drivers. It'll give you a warning here that is something we're already going to do as soon as this is done, and that will kick out the the open source basically drivers, which we don't want that. And go ahead and reboot. And when you're back to your node here, you can pop up a shell really quick and type NVIDIA-SMI. And you'll see that, well, it's not a clean display really, but we can do something a little bit better here. We're going to do an apt install NVTop. And NVTop will do a much better job of displaying a kind of graphically friendly way to view your GPU statuses. So NVTop. And there you go. You can see the 4 3090s that we've got. There we have it. That's pretty awesome. So our system is capable of now talking to them, but there's communication that has to happen from the LXC Docker to them for that to happen. And on the Proxmox host, we also need to run apt install Nvidia Container Toolkit, and also to configure the runtime. So I'm going to close out the terminal that I've got here, and we're going to go to T-Tex, GitHub IO, and he has got just some great stuff here. If you have not taken a chance to use this, it can greatly speed up your deployments, so I really recommend you doing it. So I believe that he has this one under Docker K8. So we're just going to grab the Docker LXC. I would also recommend people read through the script, because passing this to your system like this can be kind of dangerous, actually. But there are a lot of people that are looking at it. It's not to say that I've vouched for this, but you should definitely go to and read that shell script yourself before you just blindly execute it. So go back and use your shell for this, just so that it can get the variables correct. So we're going to paste that in, click yes. The default settings are going to be fine for us, and then we can adjust it inside the LXC itself. And we're going to actually use the storage pool for this. That'll give us quite a bit more space. Click no here and install something like Dockge or something. And we'll go ahead and install Compose as well. And that's it. So you can just type exit to close out of the terminal. And we've got our Docker container running here now. And if we go to the console, we can do a lsblk, and you should see that you have access to the root file system. Always take a backup of your containers before you do anything with them, and you should probably put them on a schedule with Proxmox Backup Server. I know I will be, and that'll be an exciting video that we'll be doing here shortly. Okay, so the next thing that you want to do is go to your resources really quick. Adjust this to be 64 gigabytes or a larger amount than what the 2 gigabyte is. I would say at least 16 is what you should be aiming for. 65536 is what I shot for. The way to do this is multiply the number of gigabytes that you would like by 1024, and that is the number you need to put in here. Whether or not you up the swap or not, I just leave it alone. Whether I should zero that out, tell me in the comments below. And the cores that we have, I've upped mine to 32. And you can see that on the Prox 0 system that we've got here, we have 128. Those are hyper-threaded also, so 64 is the actual number of physical cores. So 32 is quite generous to this Docker instance that we have here. Increase the size of your disk from, I believe it's going to be 4 gigs up to add on another 10 gigs. So you can do that by clicking on the root disk and going to volume action and resize. Enter 10 here. This is how many additional, not the total that you want, but how many additional gigabytes you'd like to add. Click on resize disk and it'll automatically apply that inside there. So the next thing that we need to do after we have got to this stage is we're going to run a couple of commands here so that we can go ahead. We're going to need to also install the Nvidia drivers inside here as well. And also the Nvidia Container Toolkit will get installed inside here as well. But that's actually the same process that we used last time. And if you check the history that I'm going to output here, I'm going to show you what those commands are. And like I mentioned, digitalspaceport.com, I will have all those commands there for you. So you can just start basically at 15. And I also installed HTOP and glances, but this will install the GPG. Actually, I didn't have GPG installed, so I had to install that for the privacy keys and then go back and run this. And then after this, you're going to go ahead and install all of your common packages for running an executable. You're going to then echo your keyring so that you've got the Nvidia drivers. Then run apt update. After that, run apt install Nvidia blah, 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 and it will update everything. Go ahead and reboot, and then at that point, you can run NVTOP. And when you run NVTOP, you're going to see that you have your GPUs now accessible inside your container. So at this point, go ahead and shut down. You can just click on stop your container, and as soon as your container is stopped, go back over to your Proxmox instance here and click on your shell. And from here, we're going to go to cd into our /etc/pve/LXC directory. You can do an ls. You can see that this is the first one, so this is 100. And now before we go ahead and edit this file, go ahead and run ls-al /dev/NVIDIA*. This is going to output the IDs for you, and you're going to grab them from this block up here. I'm not sure what these are down here. I don't see myself needing them. Everything seems to be working without that. But go ahead, copy these, and put it over in a notepad, because you're going to need to take this notepad and do some editing with two of these values, this value and this value. But you're also going to need to use your own logic and reasoning here as well. As you can see, I've got 4 GPUs, 0, 1, 2, 3. So that is the 4 GPUs that we're going to be accessing inside here. So go ahead and type in nano100.conf. And as you scroll down to the bottom, you'll see that I have the LXC.cgroup2.device.allow, and then the control groups of 195 and 511. You're going to need to make sure that those match the numbers that you had over here. So 195 and 511 should be those 2 number groups that you have listed over there. Underneath that, you're going to create an entry point for each one of the GPUs. So that's 0, 1, 2, 3. And you're basically mapping the external to the internal here. So you can see that that's 3 and 3. You're going to give it none, bind, optional, create, and a file. So that'll be able to hit that whenever it needs to access it. Next, you're going to come over to the LXC next entry point, and you're going to add in the Nvidia CTL, which is right here. And then you're going to do your UVM, which is right here. And then you're going to do your UVM tools, which is right here. So make sure that each one of these has a mapped point inside your configuration for your 100 container, your container that is your Docker host container. Hit Control X and yes to write that out. And then you can just exit out of this and start your Docker back up. Any container that you want to access those GPUs from in the future, even if multiple containers are running at the same time, just add those lines in and you'll be able to access them. So next we're going to do apt install NVTOP, and I've already got NVTOP installed, but if you just run NVTOP now, you'll see the 4 GPUs that we've got are now accessible inside the container. So hit F10 to exit out of that. So the next thing that we need to do is install the Nvidia Container Toolkit. So to do that, we'll type apt install Nvidia Container Toolkit. And I've already got it installed here as well. When you're back here, go ahead and nano into this TOML file and come down here to your no-c groups. This will actually be commented out, so get rid of that. and make sure that this is not false, but instead true. Hit Control X, yes, and go ahead and restart your container again. Okay, next thing that we're going to do is make sure that we can actually access our Nvidia GPUs from inside Docker here. And we'll just run this quick test, and you can see that it does hit those. So we now have things set up to run our container toolkit inside here and access the Docker containers. So we can see that I've got everything up and running that I need to have up and running at this point in time. So inside my Docker containers now, which we're going to do that next, we're going to go ahead and install OpenWebUI's Docker container from inside our Docker host here. And then we're going to access that, pull down a model, and make sure everything works. So the next thing that we're going to do is install the Dockge Docker manager here. You can customize this if you would need to, but in our scenario, which if you're following along with this, you probably don't need to, because we're going to be controlling the size and growing the size as we need from inside the Proxmox container. So that gives us a lot more flexibility than people trying to necessarily edit this. Especially if you're new, I would recommend you not edit anything here. So you can just come to the GitHub repository, link to this in the description below. Click on the little copy icon over here. Come back over to your container manager here. We're going to F10 to get out of that. And we do need to go ahead and do a sudo apt install git, which maybe it's installed already. Okay, it is. And we'll go ahead and paste this. And it is now pulling down the Docker manager that's called Dockge. And it's going to be living on port 5000 of the remote machine. So I'll show you how we're going to access that here in just a second. Okay, so it's up and running. So we can take the IP address that this machine has. And again, you can find that by going to IP space A, and it should be 20. Yep, 200. And here we're going to type in port 5001. And it's going to have us create a username for ourselves. So just going to give myself the DSP treatment here. Okay, so we've got our Docker manager up. Now, this is kind of cool. You see this bar that you're presented with here that says Docker run. This can automatically convert to compose, and that is something that's very handy. So you can always get to this just by clicking the upper left-hand icon. If you ever get just a Docker thing that you need to run, put it in there. That way you can get that formatted. And if we come over to OpenWebUI, which is a great user interface, but again, one of the strengths of this is that we can use all the user interfaces out there now. We are not limited to tying it to one because of a VM or something like that. Let's see. So if we go to Get OpenWebUI here, and we scroll down a little bit, that gives us multiple options. We're going to select the one that is to run the OpenWebUI with Nvidia GPU support. And this is going to be on, the bundled Ollama support. So that's probably what most people are going to want. And that is going to be about halfway through. So with GPU support, utilize GPU resources for running the following command is what we need to run. So really quick, this is a Docker command. So converting it to compose will be handy for us. And the port that we'll be accessing it on is port 3000. Internally to the container, it will be port 8080. It's going to use all the GPUs. It's going to install Ollama and run it inside the container as well. And it's going to keep everything restarted whenever we restart. So you can just click the copy on this one here and come back over to the Dockge interface. And now we can go ahead and hit save and start. And it will pull down everything that it needs here as it's running. And you can see in the readout there that it did find the GPUs. Perfect. Now to access this, we're going to go to port 3000. This is the external port. 8080 would be the internal port. So we're going to go to 192.168.1.200 and port 3000. All right, so now you can see that we've gone to a address which is port 3000, not HTTPS secured. So that would be something you would want to change also. And the first time you're going to click sign up. Again, this doesn't create and send data anywhere, so this is just for you locally. I'm going to go ahead and give it my DSP name. And the email you should put in good, so that if you do need to reset your password, it can send you a password reset. Okay, cool. So we are in. Now, there is something at this point that you have to consider. So we had just enough space on our disk to install everything and get it to this point. So if we take a look over here at our summary, you can see that we've got 11.48 gigabytes of 14 gigabytes used. So what models are you going to be after? So that's going to play a big deal in what size you go for. Now, if I go to the admin settings over here and settings and models, I can click here and go over to their library, and it'll give us the size that we would need for the download of that model. We're just going to do the Llama 3.18B here today so that it can get down pretty quick here. And you can see that it gives you the file size needed. That's 4.7 gigabytes. So if you check out 7DB, you can see that's 40 gigabytes. And if you check out 405B, you can see that's 229. So if I really wanted to fit everything in here, I'd go ahead and give myself probably 300. So I'm going to go ahead and do that really quick so we can just test out a couple things. I know everybody likes testing things out, right? So let's test out some stuff. So I'm going to volume action, resize, and I'm going to give it 300 additional gigabytes of space. And just like that fast it is done. You can see the summary reflects the new size of the available space here, and that'll give us enough space that we can download all of these and not run out of room. We're going to start with that 8B though and grab it here. So come on over to your panel and pull a model from Ollama. So you can just get rid of that part there, and we're going to grab Llama 3.1 8B and click the download button, and it will download it here to you. And this over here. And inside the console window, I'm going to run NVTop. And you can see the summary over here, basically growing as the size of the download increases. And now you've got a machine that can be used for so much more than just a Docker host or something like that. So you can run unlimited amounts of VMs now on it. You can easily run a bunch of different LXCs. I showed you the steps that you would need to take to be able to access the GPUs inside those different LXCs. So things like surveillance, recognition, other front ends for running LLMs, all of these things are now possible for you to run. Okay, so successfully downloaded. So we should be pretty good to get up and running with this here shortly. Let me move this over here, and we'll go to the workspace really quick and do a new chat. And I'll type hello here and select from the drop-down the Llama 3.1 8B. And we'll pull that back up so that we can watch those GPUs chug. And that is so cool that it's able to do that. And as soon as the host mem loads up with the, oh, pretty close here, the model, it's going to give us a response back. And we can ask it something like, tell me a story about a cat in 4,000 words. Roughly that amount of tokens is what would be created by asking it for that. And then we'll check what we're getting as far as the performance, as far as tokens per second. And if you look over here, you can see that this is all running inside of just one GPU. and it's only eating 6.636 gigabytes of space, so that would easily fit inside an 8 gigabyte VRAM GPU for an 8B. And if we go over here, we can see that we were hitting about 97.45 response tokens per second. So that's really good. That's a great speed. Now, let's go ahead and check the 70B. That's actually what we were getting outside of this. If you followed the other tutorials that I've been doing, check the history on some of the other produced videos to see that yourself, but that actually runs just about the same speed that we were seeing inside and outside. So bare VM, 2 container inside an LXC, almost no performance difference. I can't see a performance difference. And that exact question, I have asked it before. So let's go ahead and pull the 70 and just check that one out really quick. Make sure that the 4 GPUs will work at the same time. Have a very good feeling they will, but maybe it's not a bad idea to check. And you can just type in llama 3.1 7dB to download that. And so now we've got our model downloaded. You can see it's 37.2 gigabytes of space for that one. So we'll come back over to a new chat window here, and I'll select the 70B. And tell me, I'll give it a warm up. That'll load it into RAM first. So hello. Okay, and I'll ask it the same prompt. And we'll see if it's right around 17 or so tokens a second. So tell me a story about a cat in 4,000 words. And it looks like it's probably going to come in somewhere around 17. That just seems like about the speed. Lower than 15, I start getting kind of annoyed. Lower than 10, I'm like, today. And certainly the 405B hitting in the single digits, low single digits at that, it gets pretty annoying. But again, that is layering over on physical VRAM to system VRAM. So running a second rig might be able to get me there. From what I can see, the 405B in a Quant 4 would need somewhere around 12 GPUs. I don't know how far I'm willing to go, but I'm willing to go pretty far. That's what I do know at this point in time. And you can see that the GPUs here for inference workload really not killed. I mean, 4 at 16x, 4 at 16x, 4 at 16x, 4 at 16x, not moving tremendous amounts of data back and forth. It really is just the initial loading of the model. However, that's very different if you are doing something like training. And certainly if you're doing things like RAG, it definitely will kick it up there a bit more. And it's still going, which is good, because asking it to do 4,000 on a larger model where it has that context window capacity is something it should be able to do. On the smaller models, usually kind of janks out a little bit early, sometimes I've found. Okay, and let's check that tokens per second right there, 17.68. It's almost exactly the same that we were getting on bare metal. So this is great. We now have a system that we can take forward into the future, and it'll be the basis of most of the videos that you see on this channel. You'll see this a lot. So if you want to follow along with this guide, I highly recommend it because it'll tie in to all the videos I'm releasing in the future that give you hands-on of how to host your own killer AI and experiment, learn with me, and teach me also, because I'm reading those comments every single time, and I'm learning a lot from you all also, and especially on Docker. Okay with Docker, but I'm not good at it at any instance. And especially with LXC, I'm kind of wondering about the C groups. Like, am I sidestepping the C group need by unprivileging the container? I don't know. So we went through the complete setup of Proxmox. We also went through the setup of a GPU-based LXC and the pass-through of the GPUs to it. We also set up Docker inside there through Dockge, and we were able to see what it looks like, the performance between bare metal and virtualized inside a container, and really it is almost the same. So that gives us a lot of capabilities. As well, any other LXCs that you want to install can use your GPU. Have a home server, have an NVR, have any sort of transcoding tasks, they can all use these GPUs at the same time through this one command that I showed you. Make sure you check that out at digitalspaceport.com. I hope you have had a good time. Do drop a comment. Let me know what you'd like to see in that next video down below. I do read all of those and I respond to almost every one of them I can, but I am looking forward to reading those and I hope you are having a great day. I will check you guys out next time.